this video I want to talk about how we can parse by reference. In previous videos we talked about how we can parse by value essentially. So in this slide I have the differences laid out for us. If you parse by value, then each time you call the function it's essentially going to create new variables for the formal parameters as they are declared, and with the function call it's going to copy the value of the arguments. So not the address of the arguments but the value stored. And then these copies have a local scope. These formal parameters, also referred to as value parameters, and they will be destroyed when the function returns. And that is similar to creating local variables as I explained in previous lectures. So within a code block or a compound statement, and once you return out of that compound statement, so basically when execution moves beyond that final curly bracket, closing curly bracket, then the local variables will get destroyed. That's not very useful if you want to make changes to the local variables. So let's say the parameters that we pass in from the parent function, let's say we want to make changes to those and have those changes reflect in the parent function, in the calling function. How can we do that? Well, that brings me to reference parameters. And this is referred to as parsing by reference. So modifications to the formal parameters in the body of the function will reflect in the arguments or in the variables used in the function call. At this point you are familiar with references already, right? So you can see in the, well, firstly in the demo above, I just have some ABS function, and you can see I just have a regular variable in there. Whereas the example at the bottom of the slide, void swap int, and then I have these two parameters, which are reference parameters in this case. And you can see these are similar to how you would declare reference variables, right? You simply use the ampersand symbol, so let's say int, the ampersand, and then x. And so that's basically the difference. We declare the function to have reference parameters instead of variables, as we are familiar with at this point. And this basically means that the formal parameter will become an alias for the actual parameter or for the argument that you pass in. So in the swap_int function, that x reference parameter will have the same address as the argument that you pass in. So here I have a very typical example. I have a function called swap_int, and I want to swap the integers that I pass into this function. So I do integer p, integer q, and you can see that those are references. I use the ampersand, and then I do int temp and I initialize that to p, and I call the function down here, swap_int, I pass in x and y, then I do p, I set that to q, again q will in this case be y, and then I set q, which will be y, to temp, which was initialized to what x was, which was 5. So in that way you swap those two around, and it's just a void function. I'm not returning anything, and you can see why I covered references before I went into parsing by reference, because these are references. So I call swap_int x and y, so essentially in that instance of the function call, here where I do this integer, p is going to be an alias for x, and then q is going to be an alias for y. So you're not creating copies of x and y, you are simply creating aliases for those. And as we've seen in the lectures on references, once you make a change to a reference, that is going to reflect in the original variable as well. Okay, and here I simply do this print out, so I print out what x and y is originally, and then after we've swapped those, after the function call, I print those out once more. And I simply use the \t to add a tab between these. Here I do x and then I do x here, then I do a tab and I print out y as well with the colon, and then I print out y. I'll just build and run that and we can see what happens. First print out we get x and y 5 and 97. In the second print out we get x 97 and y 5. So those swapped around successfully. Okay, in this example I have two functions, input scores and get average score. Now input scores is a void function. It takes in 3 arguments, but you can see that these are references. So the formal parameters are references. It's going to create an alias for whatever we pass in. Then I'm basically doing input in this function. So I do cin for x, y, and z. If I go back to the main function, you'll see I have these 3 integers. And then I do input score, score 1, score 2, and score 3. So whatever I enter in the input scores function, those changes will reflect in the arguments that we pass in. So these variables here will change because again, these are references to those variables. Then I have another function, again the get average score function. This returns a float and it has 3 formal parameters, and all I do is I return this here, x plus y plus z, and to get a float back, I do divide by 3.0f. Remember the f, otherwise we are going to get a double, and then you may get a warning. But I showed you this trick in the first module. So here it's basically going to use the floating point division as opposed to integer, because we have integers here, but this is a float, and if you have a float on either side, it's going to get converted to a float. So I'm just using that trick once again. Of course, you can use floats for these. If you wanted to, you can use floats. So in terms of memory usage, it doesn't really matter if you use integers or floats. So in main I have another variable which is a float. It is called average score, and after we do input scores, I set average score to whatever get average score returns. I pass in score 1, score 2 and score 3. This is an example of passing by value, as we have done it primarily in the first module. You can see these are value parameters and these are reference parameters. So again, these will create references or aliases to the argument that you pass in, whereas these will essentially create a local copy, which will exist in memory for the duration of that function execution. Once the function will exit, then we'll destroy the local variables and will return some literal, which will essentially be here, which will then get assigned to this variable. And then we simply print out what that average score is. Build and run that. Maybe do 8, 3 and 10, and then you'll get something like 7, 8, 2 and 10, and you'll get some float. Okay, I'd like to mention a couple of things before I end this example off. So with input scores, we have these references. Now, as I explained in the lecture on references, those will expect a variable. So for example, if I add a 2 in here, we'll get an error. And if you hover over that, you'll get an error message such as initial value of a reference to non-const must be an L value. Now basically this means this needs to be some sort of a variable or something, some expression that returns a memory address, okay, because the reference is going to essentially reference that memory address, so that a variable in memory. I'll just change that back. That is one limitation that you do have when you use references. In input scores, we are actually changing the values. We do cin, so console input, and that will of course change the values. But with get average score, we are not changing the values, we are simply returning something, so not attempting to change the arguments that are passed in. Alright, so what we can do, so you can do constant references as well if you want to do that. Now this is more memory efficient since you are not creating a new variable, you are simply referencing the variable that is passed in, and what you pass in is safe with a const qualifier, since the compiler won't allow us to modify the reference variable. If you try and modify it, we'll get an error. Now both the reference variable x and score1 will refer to the same object or address in memory, and both of these will work just fine. Yeah. Actually, I'll remove this inline right here. So that works fine. And then in get average score, of course, we can now add a literal if you want to do that. Okay, we won't get any errors for that. I'll just undo. If you pass in a literal, the compiler will essentially create a constant integer behind the scenes. And then a few notes on passing by reference. So a function can return one value, such as an integer or a float for example, or it can be void, right? We are familiar with this at this point. Now it's considered bad practice to return a value from a function using the return keyword, right? And also having one or more reference parameters. So if you want a function to return more than one value, typically what you do is you write a void function with reference parameters, and in that way you can essentially change multiple variables in that function or return multiple values from that function back to the caller. You also have const reference parameters, so you can qualify a reference parameter to be const. The compiler will then ensure that the statements in the function do not modify the parameter. Now this is more memory efficient than passing by value because no new variables are created. right? It is still simply a reference, but the reference is const, so you cannot go and make changes to the argument that you pass in. Of course, with regular types such as integers and floats and so on, you won't see much of a difference, but once you start passing huge things around, so objects, for example, or instances of classes and structs, those can be huge, and if you pass those around, or in other words, if you have to make a copy of those, then it can be very expensive. So in that case, it may be a good idea to pass them in as a reference instead. And then if you want to make sure that those won't be modified, you can qualify those references as const.